On February 26, 2022, just 2 days after the start of the conflict in Ukraine, Russian forces deployed a weapon that would fundamentally alter how modern armored warfare is understood. A single missile, fired from a relatively compact launcher, struck a Ukrainian armored vehicle with devastating precision. That weapon was the Kornet anti-tank guided missile system, and what happened next would send shockwaves through defense establishments worldwide. The question isn't just whether this Russian system works. Recent combat data shows it absolutely does. The real question is how a missile system that costs roughly $26,000 can consistently defeat tanks worth over $10 million. And more importantly, what does this mean for the future of armored combat? Stay with me, because by the end of this video, you'll understand not only how these systems function at a technical level, but also why major military powers are completely rethinking their approach to armored warfare. What you're about to discover might surprise you, especially when we reveal the recent battlefield statistics that defense analysts initially refused to believe. The story of modern Russian anti-tank guided missiles begins not with recent conflicts, but decades ago during the Cold War. To understand where we are today, we need to first grasp where this technology originated. During the 1970s and 80s, the Soviet Union faced a significant problem. NATO forces, particularly the United States and West Germany, were deploying increasingly sophisticated tanks with advanced armor protection. The Moon Abrams and Leopard 2 represented a quantum leap in armored vehicle survivability. Traditional anti-tank weapons were becoming obsolete. Soviet military planners recognized that wire-guided missiles like the Fagot and Konkurs, while effective for their time, had fundamental limitations. The guidance wires could break, maximum range was constrained, and the systems were vulnerable to electronic countermeasures. Something more capable was needed. In the late 1980s, engineers at the Tula Instrument Design Bureau began developing what would become the Kornet system. The project designation was 9M133. But it would eventually receive the NATO reporting name AT-14 Spriggan. The design philosophy was revolutionary for its time. Create a modular, universal system that could engage multiple target types from various platforms using laser beam guidance. The technical innovation here deserves explanation. Unlike wire-guided systems where commands travel through physical cables, the Kornet uses what's called laser beam riding guidance. Think of it this way. The launcher continuously illuminates the target with an invisible laser beam. The missile has sensors that detect this beam and automatically adjusts its flight path to stay centered on it. As long as the operator keeps the laser pointed at the target, the missile will hit. This might sound simple, but the engineering required is extraordinarily complex. The missile must process guidance corrections multiple times per second while traveling at 300 meters per second. The laser system must be precise enough to paint a target at distances up to 10,000 meters in the newest variants. And the entire system must function reliably in rain, fog, dust, and smoke. For those wondering about the members and donors who make this content possible, thank you sincerely for your support. Every contribution, no matter the size, helps us continue creating detailed military analysis that cuts through the noise. The Kornet entered service with the Russian military in 1998, replacing older systems in frontline units. Its export variant, the Kornet-E, quickly attracted international attention. Countries including Syria, Jordan, India, Greece, Turkey, and Peru acquired the system. But its true capabilities wouldn't be fully demonstrated until it saw actual combat. The first confirmed combat use occurred during the Iraq War in 2003. Iraqi forces, equipped with export-model Kornets, engaged American Moon Abrams tanks. Initial reports were confusing and contradictory. Some sources claimed multiple Abrams tanks were destroyed by Kornets, while later analysis suggested many losses were actually due to friendly fire or rocket-propelled grenades. This confusion is important because it illustrates a critical point about evaluating weapons in combat. Battlefield fog of war makes precise attribution difficult. However, subsequent conflicts provided clearer data. In the 2006 Lebanon War, Hezbollah forces used Kornets with devastating effect against Israeli Merkava tanks. These engagements were better documented and demonstrated that the Kornet could penetrate even modern composite armor when employed correctly. Let's examine the technical specifications that make this possible. The standard Kornet missile carries a tandem warhead, meaning it actually has two explosive charges arranged in sequence. The first charge detonates explosive reactive armor, those distinctive blocks you see on modern tanks designed to deflect incoming projectiles. A fraction of a second later, the main charge penetrates the underlying armor. This tandem configuration can defeat armor up to 1,200 millimeters thick. To put that in perspective, most modern main battle tanks have frontal armor equivalent to between 600 and 1,000 millimeters of rolled homogeneous steel. The Kornet has more than sufficient penetration capability to defeat any tank currently in service, assuming it strikes a vulnerable location. The upgraded Kornet-EM variant, introduced in recent years, extends maximum range to 10,000 meters and incorporates several significant improvements. Most notably, it features automated target tracking. Earlier versions required the operator to manually keep the crosshair on target throughout the missile's flight, typically 15 to 20 seconds. This manual tracking exposed the operator to counter battery fire. The Kornet-EM changes this equation. The operator designates the target, and an automated tracking system takes over, using thermal imaging and pattern recognition to follow the target. The operator can then focus on identifying additional threats or relocating to avoid return fire. While not true fire-and-forget capability, this automation significantly reduces operator workload and exposure. Recent battlefield innovations include remote-controlled launchers. In July 2023, Russian forces first employed Kornets with the Kurgan remote control system, allowing operators to engage targets from positions up to 100 meters away from the actual launcher. High-Precision Systems, part of the state-owned Rostec Corporation, announced in early 2025 that this remote-controlled variant had passed all essential tests and was combat-ready. But here's where the story takes an unexpected turn, something that defense analysts are still grappling with. In late 2024 and early 2025, Rosoboronexport presented further developments at international defense exhibitions. At IDEX 2025 in Abu Dhabi and IQDEX 2025 in Baghdad, they showcased the Kornet-EM mounted on the Kamaz 53949 Typhoon K mine-resistant vehicle, creating a mobile platform capable of engaging targets at extreme range while providing crew protection. Additionally, they introduced the 9M134 Bulat guided missile, a lightweight variant weighing approximately 1/4 as much as standard Kornet ammunition. This addresses a key limitation of the Kornet system: weight. The complete tripod-mounted Kornet weighs approximately 63.7 kilograms, significantly heavier than man-portable systems like the American Javelin. The Bulat missile allows infantry teams to carry more ammunition without increasing their load burden. Now, let's address cost, because this is where the economic implications become startling. Media reports from 2019 estimated the cost of a single Kornet missile at approximately $26,000. More recent industry sources suggest prices ranging from $25,000 to $30,000, depending on variant and purchase quantity. Compare this to Western equivalents. The American FGM-148 Javelin, frequently cited as the most capable man-portable anti-tank system, costs between $160,000 and $216,000 per missile, depending on the specific variant. Recent contracts have shown prices approaching or exceeding $200,000 for the latest G-model Javelins. This creates a remarkable asymmetry. A Kornet missile costing approximately $26,000 can destroy an Moan Abrams tank valued at over $10 million. The economic exchange ratio is approximately 1 to 385. Even accounting for the fact that not every missile achieves a kill, the cost-effectiveness is extraordinary. Military analysts call this the economics of precision warfare. When relatively inexpensive precision-guided munitions can reliably destroy extraordinarily expensive platforms, it fundamentally alters strategic calculations. Countries can no longer rely solely on having the most advanced and expensive equipment. They must also consider vulnerability to cost-effective precision weapons. The Ukraine conflict, which began in February 2022, has provided extensive real-world data on both Russian and Western anti-tank systems. By early 2025, multiple confirmed instances existed of Kornets destroying Western-supplied armor. In the Zaporozhye region, Russian forces using Kornets struck two British-made Challenger 2 tanks. Yevgeny Belitsky, acting governor of the region, confirmed these engagements, noting that one tank caught fire after being hit. Given that only a limited number of Challenger 2s have been supplied to Ukraine, each loss represents a significant capability reduction. Near Avdiivka, documented video evidence showed a Kornet team engaging a Ukrainian Mona SA Abrams tank. The footage captured the missile just before impact. While the crew reportedly survived and evacuated, the tank was rendered inoperable. Multiple additional engagements involving Leopard 2 tanks have been documented, with Russian sources claiming numerous confirmed kills. It's important to note that these Western tanks were specifically designed to survive on the modern battlefield. They incorporate composite armor, explosive reactive armor, and in some cases, active protection systems. Yet Kornet missiles have proven capable of defeating these defenses when employed correctly. Does this mean the Kornet is superior to all Western anti-tank systems? That's an oversimplification. Military effectiveness depends on the complete operational context, not just individual weapon performance. Consider the American Javelin. It uses a completely different approach, fire and forget guidance with top attack capability. The operator locks onto the target using infrared imaging, fires the missile, and can immediately seek cover. The Javelin climbs above the target and attacks from above, where armor is typically thinnest. This provides significant tactical advantages. The operator isn't exposed for the 15 to 20 seconds required to guide a Kornet to target. Multiple soldiers can fire javelins simultaneously without coordination, since each missile independently tracks its target. And the top attack profile maximizes armor penetration against the vulnerable top surfaces of tanks. However, the Javelin has limitations that the Kornet doesn't share. Maximum range is approximately 4,000 meters compared to the Kornet's 10,000 meters. This is militarily significant. Tank main guns typically engage targets effectively out to approximately 2,000 meters. The Kornet can engage tanks from well beyond their ability to return fire. The Javelin cannot. Additionally, the Javelin's infrared seeker can be confused by environmental conditions. Smoke, fog, heavy rain, or even certain types of terrain can prevent target lock. The Kornet's laser guidance is more resistant to environmental interference, though not immune. Smoke screens can disrupt the laser beam. In terms of armor penetration, the Javelin achieves between 600 and 800 millimeters according to various sources. This is sufficient to defeat most tanks from the top, where armor is thinner but potentially inadequate against frontal armor of the most heavily protected vehicles. The Kornet's 1,200mm penetration provides greater margin against all aspects of modern tank armor. So which system is better? The answer depends entirely on the tactical situation. For infantry operating in close terrain with limited visibility, the Javelin's fire and forget capability and ease of use provide clear advantages. For vehicle-mounted systems engaging targets at extended range in open terrain, the Kornet's greater range and penetration may prove more valuable. Russian doctrine has historically emphasized vehicle-mounted anti-tank systems. The Kornet reflects this. While it can be deployed on a tripod by infantry, it's optimized for vehicle mounting. This allows two-man crews to operate the system while benefiting from mobility and protection. Western doctrine, particularly American, emphasizes man-portable systems for infantry. The Javelin reflects this. At approximately 22.7 kilograms for the complete system, a single soldier can carry and fire it without support. This provides greater tactical flexibility in complex terrain. Neither approach is inherently superior. They reflect different operational philosophies developed over decades based on expected employment scenarios. One area where the Kornet has demonstrated unexpected versatility is engaging aerial targets. Recent Kornet-EM variants can engage low-flying helicopters, reconnaissance drones, and even some strike drones. The system's laser guidance and automated tracking make it effective against relatively slow-moving aerial targets within its engagement envelope. This capability became particularly relevant as drone warfare proliferated in recent conflicts. While purpose-built air defense systems remain more effective against aerial threats, having anti-tank systems that can engage both ground and aerial targets provides additional tactical flexibility. In October 2023, Hezbollah forces employed Kornets mounted on the Tharala twin ATGM system. This quadrupod arrangement mounts 2 Kornets for rapid successive firing. The tactical logic is ingenious. Modern tanks often carry active protection systems that can intercept incoming missiles. The Israeli trophy system, for example, can detect, track, and destroy approaching anti-tank missiles before impact. However, these active protection systems typically require several seconds to reset after engaging a threat. By firing 2 Kornets in rapid succession, the first missile triggers the active protection system and the second missile strikes before the system can reset. This represents tactical adaptation to defensive countermeasures. At this point, you might be wondering about the broader strategic implications. If relatively inexpensive anti-tank missiles can defeat extremely expensive main battle tanks, does this mean tanks are obsolete? This question has been asked repeatedly throughout history. After the First World War, some analysts predicted that tanks made cavalry obsolete. After early anti-tank weapons appeared, some predicted tanks themselves were obsolete. After precision-guided munitions emerged, some again predicted the end of armored warfare. Each time, these predictions proved premature. Tanks evolved, incorporating better armor, active protection, and new tactics. The same pattern is occurring now. Modern main battle tanks are incorporating increasingly sophisticated active protection systems. The Israeli trophy system, Russian Afghanet system, and American trophy variants can defeat many anti-tank missiles. However, these systems are expensive, add weight, and have limitations. They can be overwhelmed by simultaneous attacks or defeated by tactics like the Tharala twin launcher approach. Tanks are also being employed differently. Rather than operating in large formations as they might have during the Cold War, modern tank units increasingly operate in combined arms teams with extensive infantry support, electronic warfare assets, and air defense coverage. This integrated approach makes individual tanks harder to target. Additionally, manufacturers are developing new armor technologies. Reactive armor continues to evolve, with newer systems designed to defeat tandem warheads. Active electronically scanned array radars can detect incoming missiles earlier, providing more time for countermeasures. And novel armor materials promise better protection at lower weight. The future likely involves a continuing competition between anti-tank weapons and tank defenses, each driving evolution in the other. The Kornet represents the current state of this competition, but it won't remain static. Development continues on more advanced Russian anti-tank systems. While details remain limited, reports suggest work on systems with greater automation, improved seekers, and increased range. The goal appears to be maintaining the cost advantage while improving effectiveness against evolving defenses. One particularly interesting development showcased at the Army 2024 Forum was continued refinement of the 9M134 Bulat lightweight missile. By reducing weight while maintaining acceptable penetration capability, this expands the tactical flexibility of Kornet-equipped units. There's also evidence of development work on improved guidance systems. While the Kornet currently uses laser beam riding, which provides good accuracy and jam resistance, it requires continuous line of sight. Future variants might incorporate millimeter wave radar or dual-mode seekers combining laser and infrared guidance, though such developments remain speculative. Let's examine some specific technical details that military technology enthusiasts appreciate. The Kornet's propulsion system uses a 2-stage solid-fuel rocket motor. The first stage provides initial boost, getting the missile away from the launcher. After the missile reaches safe distance from the operator, the main motor ignites, accelerating it to cruise velocity of approximately 300 meters per second. This 2-stage approach serves several purposes. It reduces launch signature, making the firing position harder to locate. It allows safe firing from confined spaces, since the main motor doesn't ignite until the missile is clear. And it provides consistent performance across the missile's range envelope. The warhead design deserves additional explanation. The tandem configuration uses a small precursor charge, positioned ahead of the main shaped charge. When the precursor detonates against explosive reactive armor, it triggers the reactive blocks, causing them to disrupt the threat. However, because the main charge is several centimeters behind the precursor, it passes through the disrupted area before the reactive armor fully responds, allowing it to penetrate the base armor. This requires precise timing and spacing. The two charges must be positioned so the main charge arrives at the armor exactly when the reactive armor is most disrupted, but before it fully expends its energy. Engineers optimize this through extensive testing and computer modeling. The laser guidance system operates in the near-infrared spectrum, invisible to the human eye but detectable by specialized sensors. The launcher projects a modulated laser beam that encodes guidance information. The missile's tail sensors detect this beam and extract the guidance commands, adjusting control surfaces to maintain position in the beam center. One challenge with laser guidance is atmospheric effects. Dust, smoke, fog, and rain can scatter or absorb the laser beam, reducing effectiveness. Engineers mitigate this through beam shaping, power optimization, and sophisticated signal processing in the missile. However, heavy obscuration can still prevent target engagement. The thermal sights used with modern Kornet systems operate in the long-wave infrared spectrum, detecting heat signatures from targets. They provide significantly better performance in low light and through light obscuration compared to optical sights. The newest variants offer multiple magnification levels and automatic gain control to optimize image quality across different ranges and conditions. For those interested in the economic and industrial aspects, production of Kornet systems involves multiple facilities across Russia. The Tula Instrument Design Bureau handles design and development. Manufacturing occurs at several plants operated by High Precision Systems, part of the Rostec State Corporation. Export sales are managed through Rosoboronexport. This industrial structure allows relatively high production rates while maintaining quality control. Exact production numbers remain classified, but export customers and domestic military requirements suggest annual production of thousands of missiles and hundreds of launcher systems. The global proliferation of Kornet systems creates interesting strategic dynamics. Over 20 countries operate various Kornet variants, from basic Kornet-E export models to more sophisticated Kornet-EM systems. This widespread adoption provides battlefield data from diverse environments and conflicts, informing future development. It also means that Kornet systems might appear in conflicts worldwide. During recent Middle Eastern conflicts, multiple factions have employed Kornets. In the Syrian civil war, both government forces and various opposition groups used the system. This proliferation complicates conflict analysis and arms control efforts. Now, let's address a question that military professionals often debate. How does operator training impact effectiveness? A sophisticated missile system is only as capable as the personnel employing it. Russian doctrine emphasizes relatively extensive training for anti-tank missile operators. A qualified Kornet operator typically undergoes several weeks of specialized training covering system operation, tactics, maintenance, and field procedures. This training includes live fire exercises, though often with limited ammunition due to cost constraints. Compare this to the Javelin, which is designed for relative ease of use. American military sources claim a soldier can achieve basic proficiency in Javelin operation with just a few days of training. The fire-and-forget guidance reduces operator skill requirements during engagement. However, truly effective employment of any anti-tank system requires more than basic technical proficiency. Operators must understand terrain analysis, threat layer identification, position selection, camouflage, and coordination with supporting elements. These tactical skills require extensive training and experience, regardless of the specific weapon system. Combat effectiveness data, where available, suggests that well-trained operators achieve significantly higher hit rates than minimally trained personnel. The difference can be dramatic. Experienced operators might achieve hit rates above 90% under favorable conditions, while poorly trained personnel might achieve only 50 to 60%. This training factor partially explains varying performance reports from different conflicts. When well-trained units employ Kornets under favorable conditions, results can be devastating. When hastily trained personnel use them in suboptimal circumstances, results may disappoint. The importance of logistics also cannot be overstated. Anti-tank missiles require proper storage, handling, and maintenance. The Kornet has a stated shelf life of approximately 10 years under proper storage conditions. However, exposure to extreme temperatures, humidity, or physical shock can degrade performance. Units must maintain cold chains for thermal batteries, protect electronic components from moisture, and properly calibrate sights. In combat conditions, these requirements can be challenging. Logistical constraints have sometimes limited the effectiveness of even technically capable systems. Looking at comparative combat statistics where available, the Kornet and Javelin have both achieved impressive results. Ukrainian forces using Javelins claimed approximately 93% effectiveness rates in early fighting, destroying 280 Russian armored vehicles with 300 missiles, according to American officials. Russian forces using Kornets have achieved significant kills against Western-supplied armor, though exact statistics are harder to verify. Claims of 20 destroyed Abrams tanks out of 31 supplied circulate in various sources, though independent confirmation remains incomplete. Multiple documented cases exist of Challenger and Leopard tanks being destroyed or disabled by Kornet strikes. What's clear from available data is that both systems, when employed correctly by trained personnel, are highly effective against modern armored vehicles. The idea that any current tank is immune to anti-tank missiles is demonstrably false. Even the most sophisticated armor can be defeated by appropriately employed precision weapons. This brings us to the question you've been waiting for. What does all this mean for the future of ground combat? Several trends are becoming clear. First, main battle tanks remain valuable for their unique combination of firepower, protection, and mobility. However, they can no longer be employed as they were during the Cold War. The assumption that armored formations could dominate ground combat through superior platforms is obsolete. Second, combined arms integration is increasingly critical. Tanks operating without infantry support, air defense coverage, electronic warfare assets, and effective reconnaissance are extremely vulnerable. Modern warfare requires sophisticated coordination between multiple elements. Third, cost-effectiveness of precision weapons is reshaping military procurement. When relatively inexpensive missiles can destroy extremely expensive platforms, military forces must carefully consider force structure and investment priorities. Simply building the most advanced and expensive vehicles is insufficient if they can be defeated by weapons costing a fraction as much. Fourth, technological evolution continues in both offensive and defensive systems. Active protection systems, improved armor, and new countermeasures will make tanks more survivable. But anti-tank systems will also evolve, incorporating better seekers, improved warheads, and more sophisticated guidance. The Kornet system represents current state-of-the-art in one evolutionary branch of anti-tank warfare: long-range, laser-guided, heavy missiles optimized for vehicle mounting. Other branches include man-portable fire-and-forget systems like the Javelin, loitering munitions that can wait over the battlefield, and emerging technologies like hypervelocity projectiles. Each approach has strengths and weaknesses, each will continue evolving, and each will influence the others as developers respond to emerging threats and opportunities. For defense planners and military professionals, the lessons are clear. Survivability requires layered defenses, tactical sophistication, and combined arms integration. Over-reliance on any single capability, whether defensive or offensive, creates vulnerability, and maintaining technological edge requires continuous innovation and adaptation. For military analysts and enthusiasts, the Kornet story illustrates several broader principles. Technology alone doesn't determine outcomes. Employment, training, and tactical context matter enormously. Economic factors increasingly shape military effectiveness, not just technical capability, and public perception of weapons doesn't always match their actual battlefield performance. The data we've examined today comes from multiple sources, including official military publications, defense industry reports, verified combat documentation, and technical analysis from independent defense researchers. While some specific details remain classified or disputed, the overall picture is clear and well supported. Russian anti-tank guided missile technology, particularly the Kornet family, represents a mature, combat-proven capability that has successfully engaged advanced armored vehicles across multiple conflicts. Its combination of long-range, high penetration, reasonable cost, and demonstrated effectiveness makes it a significant factor in modern ground warfare. Whether this technology is better than Western equivalents like the Javelin depends entirely on the evaluation criteria and tactical context. For certain missions, the Kornet's characteristics provide advantages. For others, fire-and-forget systems excel. Military forces increasingly recognize that diverse capabilities provide more flexibility than relying on any single approach. As we've seen throughout this analysis, the evolution of anti-tank weapons and armored vehicles continues. The Kornet represents one point in this ongoing development, not a final answer. Future systems will build on lessons learned from current technology, incorporating new capabilities while addressing known limitations. What we can say with confidence is that precision anti-tank weapons have fundamentally altered ground combat. The days when armored vehicles could operate with relative impunity are over. Modern warfare requires sophisticated integration of multiple capabilities, with no single system providing complete protection or dominance. The question isn't whether systems like the Kornet work. Combat data proves they do. The question is how military forces will adapt to this reality, developing new tactics, technologies, and organizational approaches that maintain effectiveness despite the proliferation of precision weapons. Thank you for joining me on this detailed examination of Russian anti-tank guided missile technology. If you found this analysis valuable, consider subscribing for more in-depth military technology content. And remember, understanding these systems isn't about choosing sides, it's about comprehending the technical and tactical realities shaping modern warfare.